Okay, the purpose of this video is to draw a circuit together, and the symbols for drawing this circuit are in the physics reference tables. So I took this right out of the physics reference tables right here. When I'm doing a circuit, I always start with the battery personally. This is how I make the symbol for battery. I know my symbols are slightly different than the physics reference table, and that's okay. Notice that my battery importantly has a long side. That is the positive side of the battery. I would think of that as the high pressure, the high voltage side of the battery. So the electrons are going to move. Here's a wire. This is the beginning of my wire. The electrons are going to move away from the high pressure. The current is going to move up because of the way I put this. Could have drawn the battery upside down to make the current go down. Could do that too. It's no big deal. Yeah, and this is the small side of the battery, so it's the low pressure side there. So I'm going to continue my wire on, and I'm going to put a gap in the wire. When you got a gap like that, electricity can't flow. Electrons can't jump over the gap. So that's a broken circuit or a short circuit. What we're going to do is put the symbol for switch there, so you could close that and make the connection. And that's basically what you're doing when you turn something on or off. A switch in your wall, for example, is just that. It breaks the circuit. I'm going to extend the wire around the edge here, and I'm going to put a zigzag. That is a resistor. And you know what a resistor does. It blocks the flow of electrons, which of course can affect the amount of current that's able to get through. I'm going to put a special kind of resistor now. This is a light bulb. Yep, a light bulb is just a resistor. That's how I draw the light bulb. So both the light bulb and the resistor impede the flow or block the flow of electrons. And when that happens, the resistor, for example, will heat up, but it doesn't get hot enough, or it shouldn't get hot enough to catch on fire. So it would emit radiation in the infrared. You could see it with an infrared camera, night vision. However, the light bulb gets hot enough, the filament that's in there gets hot enough. Here's the filament. That gets hot enough to actually glow into the visible portion of light, and that's why we call it a light bulb. So it gets really hot and it glows, lets out photons. We're going to continue on with our wire here and reconnect to the negative side. There we are. And now we've completed our circuit. There's a couple things that we commonly put in the circuit though. We put in ammeters to measure the current. And an ammeter can go anywhere on the wire. This wire that's going all the way around in a rectangle here. Let's put one at the beginning. But just know I could put it anywhere because there's only one path for electricity to flow here, for the current to flow. It really doesn't matter where I put the ammeter. The voltmeter that measures the voltage drops around the resistor and the light bulb. That is a little different story here. You have to put that around the device. So this would be measuring the voltage drop around the resistor and the voltage drop around the light bulb. And you could put a voltmeter around the battery, and it's not going to be a drop here. This is the job of the source or the battery, is to increase the voltage back up. Okay, so that's how you draw a circuit.